Okay, so hi everyone, Senan this side, and in this video we are going to see how to solve this two keys keyboard problem. So before we get into this question, I just want to say that I don't think it's that difficult of a question, but if you see the solutions in the solution section, I don't know why they have complicated everything. Okay, so basically this is a dynamic programming problem. So there is only one character A on the screen of a notepad. You can perform one of two operations on this notepad for each step. Either you can do a copy all, or you can just paste. That's the only two things you can actually do. Now, given an integer n, return the minimum number of operations to the character A exactly n times on the screen. So the character that is here A has no significance, basically a single number for you. Okay, so let's say if n is 3, what you can do is copy once and paste it twice, so you get the answer as 3. For n is 1, your answer is 0 because you are already given a single a, right? So you just have to return that. Obviously, if you see this, n is between 1000 and 1, so that means if we initialize an array that is something that is normal and have a 1D array of thoughts, it's not that big. So let's look at the solution of how I am actually doing this. It's quite straightforward. I don't think it requires more explanation, but even after that, let's see. First of all, I initialize an array of size n plus 1 so that indexing is not an issue. So basically I am trying to go for a 1 based index in a way. So now I would initialize dp of 1 as 0. Why? Because for 1 it's already 0, right? There's nothing you could, but since I've already initialized it in this case, so I don't actually do that again. Now what I do is I start from I is equal to 2 because for 1 I know the answer for 2 and I go till the end. So what I do is I find the maximum number that can divide this I, basically the max. So the way I approach this is I start with I by 2 because the first number that can divide I and is not I is basically I by 2 and the numbers below that, any one of them. Now what I do is I find j is equal to I by 2 and I go till j is greater than 1, greater than basically 0 or greater than equal to 1, because at that case it is always a divisor. What I do is I check if I divides j. I find the biggest j that can divide I, which is not I itself. That is the whole logic of this inner for loop. And now if I found that, what I say, I take the value that I had already computed for dp of j and just add I by j value. Now this I by j in itself includes one copy and I by j minus 1 pastes, right? So that is why I do not consider, because whenever you reach any j, you assume that you already have what dp of j elements, right? Now what you have to do is copy that and paste that. So copying, the time to copy and paste is both included in this. Otherwise what you can do is one copy, and since you already have the solution for this, you assume that you have j characters already on the screen. What you do is you just paste the remainder. So basically what this is doing, this is the time to copy. You assume you already have j elements with you, and how many more elements do you require to basically make the size of this to I is I by j minus 1 is the number of times you have to paste, because you have already assumed that you have pasted j at least one time. So that is why this minus 1 is there, plus one time to copy. So in a nutshell, what you would be having is the thing that is I by j. And now when you found one, you just break out, because it's better to have 3 a's for getting a 6 to have 3 a's and just copying it twice, rather than having 2 a's and copying it twice. So 3 a's, copying it once, and 2 a's, copying it thrice to get 6. So if you want, you can just remove this as well, and you can use a minimum argument, but it would always take the first argument. And I assume that dp of j is the correct value, or the minimum number of steps that you require to have j character, and in the end you just return the last element. Now if you see the test cases, I've tried some of my own, this 4 and this 6, just to test it out. This is working fine, and when I submitted this was like beats 100%. So I think the solution is good enough, and the time complexity is about n square, because you would be going from I by 2 to 0 and decrementing it by 1. So there could be a possibility that we travel or n elements here, and about n by 2 elements order of n square. What I've seen on the solutions page are something they use prime factors or something like this and that. I don't think that's necessary. Quite too complicated stuff. You can do it like this. So yep, that was the whole video about. And if for some reason I find a better solution for this with a time complexity, I would definitely make another video for this. But for now, this is the solution that I have. And yep, the space complexity is big O of n, time is big O of n square, and I'll see you in the next video.